Okay. Greetings, everyone. My name is Numan Zahid Khan. The topic of my research is assessment of satellite-based evapotranspiration products at regional scale over landscape of Pakistan. Coming to the problem statement, recent studies have revealed that floods and droughts are increasing day by day. The increase of these extreme events is affecting biological and human systems in different ways. Floods and droughts have received special attention in Pakistan because they were the cause of great monetary losses and casualties. Estimation of evapotranspiration is essential for climate change research, including water cycle, drought or ecological forecasting, and simulating hydrological or crop heat models. Therefore, accurate estimation of evapotranspiration at regional and temporal scale is of utmost importance. Methods for assessment of evapotranspiration and their shortcomings. First of all, it is a measuring methods. We measure ET values like from instruments like lysimeters, water balance, eddy correlation coefficient. But their shortcomings are they have very low network density, very costly installation, and shows different type of systematic errors. Then comes the estimation methods. Estimation methods like energy balance, mass transfer, Penman equation, etc. But their dependability on a number of factors like leaf area index, soil water availability, soil characteristics, vapor pressure deficit, solar radiation makes it difficult to calculate ET. Then comes the satellite-based evapotranspiration products, which includes MODIS, GLDAS, GLEAM, but they have different uncertainties as well, depending upon different theories, structural assumptions, and indirect estimate of ET. Satellite-based ET products during last few decades, substantial efforts have been made in remote sensing that provide indirect estimation of actual evapotranspiration at various spatial and temporal scales. Among several global AET products, very few qualify as datasets which are widely available, possesses large coverage and find operational applications, for example, MODIS, GLDAS and GLEAM. Moreover, these products provide continuous AET datasets on a global scale which are based on Penman-Monteith equation, Priestley-Taylor and land surface model approaches respectively, and is available free of course. The objectives of my research works are characterizing the spatio-temporal behavior of evapotranspiration at regional scale, comparing the results of different ET products with the ground-based measurements calculations, and assessment of statistical significance of results of different ET products. Coming to the methodology, after literature review, I have collected data, satellite-based evapotranspiration data products and ground-based measurements taken. Three products I have used which are moderate resolution imaging spectroradiometer MODIS, GLDAS global land data assimilation system and global land evaporation and Amsterdam model. It's called GLEAM. After download and downscaling of data in NetCDF and HDF format and verify them by using Panoply softwares, and then using GIS software I have extracted their numerical values in Excel sheets, and then spatial and temporal comparative assessment has been made with these satellite products with reference data set. Then I calculated 6 statistical measures which are bias, IOA, RMS, ENSC, standard deviation, R square, and then comes the statistical significance and results. Data collection, you can see three products, satellite products, and use which version I have used given here like GLDAS V2.1 mode 16 I have used. Their special resolution time period of 2009 to 2018 for all products. Uh, you can see spatial resolution and temporal resolution have been given here. Daily and temporal resolution has been adjusted to monthly, and spatial resolution has also been adjusted accordingly. Gauge data, evapotranspiration data of 30 selected gauge stations across the whole country for the period of 10 years was obtained from Pakistan Meteorological Processing Department, Agriculture University Faisalabad and NESPAC. You can see the study area and the selected 30 selected gauge stations. Data processing, satellite evapotranspiration estimates from MODIS and GLDAS were downloaded in HDF and NetCDF formats. Then data was verified and ET of corresponding points were extracted using ArcGIS software. Then comes climatic zoning. Mean annual temperature of past 30 years was used for climatic zoning. Climatic zoning of Pakistan was performed by using geospatial analysis tool in GIS. Pakistan was divided into 4 climatic zones based on the temperature. 30 selected gauge stations were selected in all 4 zones. Gauges were selected in different zones based upon the quality and continuity of data. Then comparison was made. 4 different zones were selected across the study area, and seasonal variations, division is also here. Winter from December to February. Similarly, spring, summer, and autumn. 4 seasons are given here, and time scale monthly has been taken. To systematically assess the effectiveness of each satellite product, evapotranspiration estimates were compared with gauge data on the basis of different performance metrics, which include bias, RMSE, NSE, standard deviation, correlation coefficient, and index of agreement. Comes the results and discussion. Here, this picture shows the spatial map of GLDAS seasonal basis. You can see winter, spring, summer, and autumn. Spatial maps have been drawn, and you can see in the values lie different in different regions based on the selected gauge stations. Blue area showing the high amount of ET, which is showing GLDAS is showing. Next come the spatial map of MODIS. You can see here also the spatial maps of MODIS. You can see blue area showing a higher degree of ET values. And then comes the gleam. You can see the blue area, and blue area showing the high values of ET measured by gleam. And similarly, you can also see the annual mean as well. Winter, spring, summer, and autumn, you can see the distribution of ET values. Then comes the performance evaluation at seasonal scale. Uh, Based on the performance metrics, you can see RMSE values, root mean square error values. Gleam is performing a better, showing a little higher degree of error in winter, but in all other seasons, Gleam showing less degree of error. Similarly, bias is also a statistical base error based values, yes, showing same trend as RMSE. When it comes to the correlation coefficient, you can see Gleam is performing better than all other products in all seasons. Standard deviation shows similar type of behavior. And then comes the NSE, natural cliff efficiency. You can see Gleam is performing better. And comes the index of agreement. In agreement mode is showing better agreement in winter, but in all other season, Gleam is showing better agreement than other 2 products in all season, and GLDAS is performing intermediate between these 2 products. Then comes the zonal variation of performance metrics. You can see bias and RMSE error based values, as I discussed earlier in seasonal. In zone based, they are almost performing same as that of seasonal. As I've discussed earlier, you can see RMSE of values of Gleam is very much less than other 2 products, and correlation coefficient of R square values of Gleam is also consistently better than other 2 products. Standard deviation shows almost similar type of behavior, but comes to NSE, Nash Sutcliffe efficiency, you can see Gleam is performing better, and comes to the index of agreement, Gleam is showing better agreement in all zones than other 2 products. Then comes the conclusion. By considering zones based analysis, it was noted that Gleam performed better as compared to other ET products in all zones, whereas GLDAS and MODIS ranked second and third respectively. Gleam performed consistently better with least error, whereas GLDAS and MODIS shows comparatively high uncertainties, overall dry as well as humid regions. Seasonal analysis resulted that Gleam was best suitable product in case of spring, summer, and autumn, whereas MODIS provide better agreement in case of winter. On the other hand, GLDAS was ranked second in case of all seasons. Overall performance of Gleam product was better than other products. This study reveals that in future, Gleam can be used as an effective tool for evapotranspiration estimation in poorly gauged areas of Pakistan, especially in zone 3 and 4, which are dry areas. Performance of Gleam can be enhanced by merging its ET estimates with other state-of-the-art satellite products or by applying ensemble algorithm. Recommendations include hydrological evaluation of Gleam can be carried out for its further validation in diverse region of Pakistan, and error component systematic or maybe random estimation in satellite products can be a step further for evaluation of GLDAS and Gleam. Here are the some of the references mentioned here. Thank you for listening. Thank you for your time.
Thank you very much, Mr. Numan Zahid.